We've already solved systems of equations with two variables in three different ways, and remember our options were infinitely many, no solutions, or one answered, which was an ordered pair. Now we're going to solve systems of equations in three variables, and it works the same way. We have one solution, no solution, or infinitely many, except this time our one solution is going to look like our ordered triple. So now we're dealing with three variables, x, y, and z. This takes us away from a plane that we can graph on paper, and it takes us to space. And so now that we are working in space, these equations with x, y, and z represent planes instead of lines. And so this looks a little bit different. Our one solution is three planes that would intersect at a point. Infinitely many solutions is either where they're the same plane, all three planes are the same plane, or where the three planes intersect at a line. So either one of these would work. And then where there are no points is where maybe two planes intersect, but not all three, or you have one of these options. So how we solve systems with three equations is the same way as we do with two, except we just have to do more of it. So we're going to eliminate a variable, and then we'll have two equations, and we'll be back to how we solve. So again, it's easy if you mark these. I normally number them. Some people use A, B, C. And so I'm going to take equation 1 and equation 2 and try to do a equation to get rid of a variable. It doesn't matter which variable you can get rid of, whatever's easiest. And it also doesn't have to start with 1 and 2. You can start with 2 and 3 or 1 and 3. Whatever you see that works well for you, but you will want to do elimination for this, not substitution. So I see that I can multiply this by 2, and those would cancel. So I'm going to come in and do that. And of course, you could rewrite that if that's easier for you. This cancels. And I get 9x plus 5y equals 12. Okay, great. So now I'm down to x and y. That's awesome. Except we have to do it again. So I'm going to pick this time. And again, it doesn't matter what you pick, but I'm going to pick equation 2 and equation 3. And sorry, you might have to put your slashes in your z's so you don't get confused with 2's. And I, again, see I can multiply this by 2 and add. Now you could have used 1 and 3 and multiplied by a negative, something like that. So you have multiple options, and as long as you're careful and take your time not to make any mistakes, both of them will work well. Okay, so now that I have two equations, I'm going to number these, and we have 1, 2, 3. I'm going to call this 4 and 5. So I'm going to take 4 and 5 now and combine them to solve a system of equations. So after I've done step 1, I'm back to what we already did. In section 1, I need to find a way to get rid of one of these. You could absolutely do substitution, and these are a little bit ugly, but that's totally fine. I think I'm going to try to cancel my y's. Of course, you could do something different. And my new equations, I'm going to write my new equations and cancel. The top by negative 6 and the bottom by 5. And again, you could have done a different way. My y's canceled. Had kind of some ugly numbers, but I got to x equals negative 2, so it's not too bad. Now I have to plug this into one of my original, like E4 or E5, so that I only have my x and y. Both of them, and neither one's real pretty, so I think we're going to plug into E5. So I have 5 times a negative 2 plus 6y equals 26. So I'm going to solve for y. We get y equals 6. So I have my x value, I have my y value. Now I have to find my z, so I go back and plug into one of the original equations. 1, 2, or 3, doesn't matter which. 3 doesn't look bad. Let's do 3. So x plus 4y. And you don't have to keep up with what you plug in, what equation you're plugging into, as long as you keep track. Now here, I would highly recommend writing those equations. And so now I'm going to plug in. and solve for z. 6 times 4 is 24, minus 2 is 22. So we get 2z is negative 6, or z is negative. Now, that's not your answer. We have our x, y, and z, but my answer for a 3-system equation is order triple. So your answer, you would write, so there's your answer. So yeah, it's a little bit long problem. We did 1, 2, 3, 4 things. Let's review what we did. We took 2 equations and eliminated a variable. We took 2 other equations and eliminated the same variable. So it's really important that you then end up with your 2 new equations that only have the same 2 variables. Then you solve the system equations like normal, find your x and y, plug back into the top to find the z. Again, it doesn't matter if you cancel z first, you could cancel x. Then down here, find your y and z, and then plug in for x. But as long as you cancel, work with 2 equations, cancel the same variable, work with 2 others, cancel the same variable, then combine those 2 new ones. And then plug in and make sure your answers are order tripled. So now you can